Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on aside as we jump into the Big Ideas Math Integrated Math 1 textbook, Chapter 2 test and cumulative assessment. 18 questions for the Chapter 2 test, 8 questions for the cumulative assessment. If you were here for my Chapter 1 test and cumulative assessment, you'll know a few things. Number one, the cumulative assessment portion can get really weird with its questions. Now, in this case, we're going to have Chapter 1 and Chapter 2 intermixed in the cumulative assessment portion. Number two, I'll tend to go faster in this portion. This is the very end. We're testing to see what you know. I'll test to see what I know, I suppose. All the same, I'll still do the problems, of course, but less teaching, more doing, of course. So without further ado, I'm going to go ahead and get started. Jump to the description section down below if you'd like to download each individual PDF, and the timestamps are broken up into the individual sections and their respective problems. Without further ado, let's go ahead and get started. This is all things inequalities, folks. Here we go. Write the sentence as an inequality, numbers 1, 2, and 3. Number 1 says the sum of a number y and 9 is at least negative 1. Sum is addition. Y and 9 are summing together. It's at least negative 1. Negative 1 is the other end of the expression. Is at least also means it's greater than or equal to. Negative 1 is the least it can be, and it can be more than it. Number 2, a number r is more than 0 or less than or equal to negative 8. Now, there are a couple ors here. It's more than 0 or, and then here it says less than or equal to. So that phrasing is where you get to the inequality. But here's the thing. This is a compound inequality. This or is for the compoundness. So there's an or that's in the middle, basically, of this thing here, where r is doing two things. R can be more than 0, or r can be less than or equal to negative 8 is the way that they're going and saying that one. So those are the two in comparison. Now, that's a little bit of a, even though we were doing more of those in section 1.1, or 2.1, I should say, that's more of a section 2.5 question because it was a compound inequality. But there's the setup there. Number 3, a number k is less than 3 units from 10. And I guess it's important for me to also state that this stuff won't tell you what section it's from, and it'll mix itself up within the chapter. So it can be whatever it wants to be from 2.1 to 2.6. Anyway, a number k is less than 3 units from 10. So this one, 3 units from 10 in either direction, right? So less than 3 units from 10 means 10 in either direction. It needs to be 3 units away from either side. Less than 3 units away looks like this. Now, difference from k and 10 needs to be that one. So this looks like an absolute value to me. I can be 3 units away to the positive side or the negative side. I can go as far up as 13 or as far down as 7. I guess you can't be 13 or 7, but in between 7 and 13. That's like a 2-6 question. Okay, numbers 4 through 12, more of the meat and potatoes of what you would do with most inequalities here. Solve them, graph them. Now it says if possible, which does mean if there's a no solution, we won't graph it. Number 4, x over 2 minus 5 is greater than or equal to negative 9. I'm going to get the term by itself first by adding 5 to both sides. It's being divided by 2. We will multiply both sides by 2. Negative 4 times 2 is negative 8. X is greater than or equal to negative 8. Every value that includes negative 8 and greater than, including 0 as well, should be a solution to this set. I like to try 0. At this point, we should know how this works when I plug in 0. Is negative 5 greater than or equal to negative 9? It is. It's greater than negative 9. 0 works. I trust it. Number 5, variables on both sides of the inequality. Negative 4s is less than 6s plus 1. I'm going to subtract 6s from both sides in this case. Just get it by itself here. I know it'll be negative, and we'll deal with the negative. Negative 10s is less than positive 1. We'll divide by negative 10, which means several things. Number 1, a fraction. Number 2, change of sign. And number 3, flipped inequality. So greater than negative 1/10, like so. Now it's really hard to, my number line stuff doesn't do much other than a negative is on this side of it. Negative 1/10 is really close to 0, but I'll place it how I want to. If s is greater than it, then we go to the right. There's an open circle this time compared to the closed circle. 0, plugging into here, says 0 is less than 1, which is true. And so it looks like we're on the right side of justice. The flip seems to be the right thing to do. Number 6. I will distribute the 2 to begin with. and we get 4p plus 3 is greater than or equal to 4p plus 2. 4p's will go away through subtraction. No more variables means it's left to determine whether these constants are making a true or false statement. They're making a true statement. This statement means no matter what p is, we will always get a true solution. All real numbers are the solution set for p. I wish I could write. I'm having trouble writing this. All real numbers, our graph for that is just going to include everything. If I put 0 in the middle, it is in the middle of everything. So in that case, that's everything that p can be. Everything left, everything right. Number 7. We have a compound inequality. So guys, this is a true mix of every section so far. I mean, they're doing a lot less, and this is great. I'm looking through all 4 through 12. I don't see anything that would technically be from 2-2 or 2-3 in solving, just a simple add or simple division. There's at least more than one step per problem. So it's everything 2-4, 2-5, and 2-6. This would be section 2-5. And then anything absolute values is 2-6. But anything else before that is, 2-4. Anyway, so from here we have an and case being between -7 and 10 for the expression. But once we add 1 among all sides and then divide everything by 2, we can figure out what values c needs to be between. C must be between -3 and 11 halves. 11 halves is also 5.5 for the curious there. This one won't feature any arrows since we must be between the values. Now 11 halves is, like I said, around 5.5, so that's a little farther away from 0 than -3. 0 is a tweener. That works in this case. If I plug in 0, I say -1's between -7 and 10, which is true. So looking good. And I'll deal with it. Number 8 also out of section 2-5. And also another compound inequality. Not just a compound inequality, but a tweener compound inequality. It's a case of and. 4 minus 3a is greater than or equal to -2 and less than 13. The difference on this question is you can see that this 3a is negative, and don't disregard that right now. When I get -6 here, this is still a -3a. This being 9, I'll divide by -3, which does the several things that we talk about. It changes signs, and it changes inequality direction, like that. Now our final answers can't be written in this form. Lower bound written on the left, upper bound written on the right, like so. Inequality is always facing that direction when all said and done. So we get there, and we graph there. A between -3 and 2, which, as has been the case lately, includes 0 as a solution. Closed circles on both -3 and 2 if you'd like to try them out. 0 says 4 is between -2 and 13. Good. Number 9 is another compound inequality, but in a case of or. Or is generally a split, but they'll do whatever they do for these problems. We'll see how it works out. -5 is less than 2 minus h, or 6h plus 5 is greater than 71. These are basically 2 problems in one. I say that all the time. 2 problems in one. Now, I am going to add h to both sides. I like to get this one positive on the left side, especially with inequalities if I can help it. So we're going to add 5 over as well to make that work out. 2 plus 5 is 7. Here's h is less than 7. I'm done. Don't have to flip it. Don't have to change anything around after. Now I can subtract 5 from both sides here. And then divide both sides by 6. So h needs to be less than 7 or greater than 11. I'll write that one more time in one line. And we're graphing it. So the or case satisfies either condition of this, what I call a split. Here's 0, and then 7 and 11. We can be greater than 11 this way, less than 7 this way, including 0. We can't be 7 or 11. And it's good. See, 0 satisfies this one. -5 is less than 2. It doesn't satisfy this one. 5 is greater than 71. It doesn't need to satisfy both, just one. That's the or case. Number 10, 11, and 12 are all 2.6 absolute value types. Somewhere I'm sure we'll get a no solution. They say if possible. Maybe that's just a decoy, but that doesn't start with this problem. Absolute values by itself, we must be more than 4 units away from 0 in either direction. That means more than +4 or less than -4 for that expression. Less than -4 is outside of 4 units from 0 in either direction. We're going to subtract 8 and divide by 2 no matter how this thing plays out. And we'll see what those numbers come to be. So this one says 2q is greater than -4. This one says 2q is less than negative 12. And then we'll divide everything by 2 to solve for our q's. Remember, it's still an OR case. Q has to be greater than negative 2, or Q has to be less than negative 6. Now I'm waiting for a time that 0 won't work in a solution set. It works once again being greater than negative 2. I want to test 1 and say, look, 0 didn't work. I expected it to not work, besides a no solution. But 0 didn't work. I expected it to not work, and therefore we did it correctly. That's one of those ones where a false statement, when we look forward to a false statement, is something I want to look forward to. I want to see happen. Number 11 has a lot of negatives. In fact, the only positive I see is the variable. But it's inside the absolute value, and we have to get the absolute value by itself. So we begin by adding 5 to both sides of this. And this turns, this turns this positive, because 5 minus 4 is 1. But then we're going to divide by negative 2. Negative 5 plus 4 again is 1. Or negative 4 plus 5 is 1. We're going to divide by negative 2. Fraction, but really it's not just the fraction we have to worry about. It's a couple other things. Remember, this turns negative. It's a negative 1/2. And also the inequality flips. We're taking the absolute value of something and we're getting less than a negative number or equal to a negative number? I don't think so. That's a no solution case. This one is not graphable, or there's nothing to plot on the graph of the number line. No solution when we're less than a negative or equal to a negative, or less than 0, period. Number 12. We have 4 times the absolute value of negative 3b plus 5. Note the negative with the variable. Minus 9 is less than 7. Let's add 9 to both sides and then divide both sides by 4. And see what brings us truth. Okay, no fraction, no negatives. On the other side, no problem. Okay, we must be less than 4. That means within 4 on either side of this. I'm going to write this as an AND case because we've already seen the compound inequality version. So negative 3b plus 5 must be less than positive 4 and must be greater than negative 4. We have to be within 4 units of 0 in either direction, positive or negative. In both cases here, we can, we can solve. I'm going to this time make this 3b positive over here, whereas I will subtract 4 on this side. On this other one, again, this is just to be different, to diversify things and make sure you get practice on both of them. On this one here, I'm going to keep the negative 3b on that side. But let's solve this one first. We'll divide both sides by 3, and we get 1/3 here and b. 1/3 is less than b, but you really want to write this as b is greater than 1/3 if you had it on its own. The thing is, though, I'm probably going to use this ultimately. You'll see what I mean. But b is greater than 1/3 and then we'll get this other one. So here, this time I'll subtract 5 from both sides. And then I'll divide both sides by negative 3, which, as we recall, means an inequality flip. This will be b is less than, and this is a positive 3. So this can be a final answer right here. However, with the AND case, we can also do the single statement set, which would mean 1/3 is the lower bound. And this is why I said it kind of can look more like this. 1/3 and then b and then 3 like that. B is between 1/3 and 3 like that. So both of these are the same statement, and you could have started as a single inequality statement set to solve as well. Now we still have to graph it, and this is, I think, the first time besides the no solution case that 0 is not a solution. 3 is all the way out here, and b has to be between here and here. Now b can't be 0. Let's see that that's true. 0 plus 5 is 5. Absolute value of 5 is 5. Times 4 is 20. Minus 9 is 11. 11 less than 7? I don't think so. So that seems to hold up. Okay, number 13. You start a small baking business and you want to earn a profit of at least $250 in the first month. The expenses in the first month are $155. What are the possible revenues you need to earn to meet the profit goal? Okay, first of all, it sounds like we have, I'm just going to give you an equation to begin with. I know it's inequalities eventually, but profit is revenue minus cost. So they're talking about our profit. We want $250 profit, And we need to find what revenue minus $155 expenses will get us there. Now, we don't want it to be equal to $250. We want more than $250. We don't want $250 to be more than this. So we want this to be more than $250. We want $250 to be less than our revenue minus cost, right? So that would be my setup for this problem to begin with. So we can add 155 to both sides. And here we're now going to get 405. 405 is less than or equal to revenue. Revenue is greater than or equal to 405. We want to make, what are the possible revenues? More than $405. That's the thing. I'm good with $900. I'll take it. That'll get me at least a $250 profit. No graphing. Number 14. A manufacturer of bicycle parts requires that a bicycle chain have a width of 0.3 inches with an absolute deviation of at most 0.0003 inches. That's high demand, high demand. Write and solve an absolute value inequality that represents the acceptable widths. We have to be within 0.0003, is that right? 0.0003 inches of this difference between our bike chain width and 0.3 inches. The difference between these two must be within 0.0003. So we set that up as, I tend to do the single inequality in this one. X minus 0.3 needs to be between the positive version and negative version of this number. Now when we add this to all sides, again, I like to think of this more as 0.3 minus this and 0.3 plus this. So 0.3 plus this is pretty easy to do. That's 0.3003. My inequality things are looking more like C's. And then right here, this is 0.2997. I think that would be right. So between this many inches of width is the acceptable amount for the manufacturer, right? Between those two sets. I'll just kind of write it like that. I think that's pretty good because I left the units. We need units for that. And that's the original inequality, by the way, the absolute value inequality. Number 15. Let A, B, C, and D be constants. Describe the possible solution sets of the inequality A, X plus B is less than CX plus D. So we have to solve for X, given this. We haven't seen one of these literal equation things in a while, probably not since, well, chapter 1, but section 1.5. This is where you want to get your X terms on one side of the equation. So I'm going to subtract CX from both sides. And I'm going to subtract B from both sides because B doesn't have any X term in it. So here I have AX minus CX. And you might think that these two can't combine. And I get it. They kind of can't combine. But they kind of can. A minus C can still represent a quantity that's multiplying by X. So we can put them together in parentheses, multiply by X. This is another way of saying we factored out X. Didn't know if we'd see that again. And because it's multiplying by it, we can divide both sides by that single quantity to get 1 over here. Whoops. And then over here we got this. A minus C. And so now X can be less than whatever D minus B over A minus C is, like that. Now the only thing that I'm not sure about, here is that, see, if A minus C is a negative number, then we'd be swapping the inequality. So this is one version of what it could be, given that A minus C was a positive number. If A minus C is greater than 0, because I don't know anything about that possibly being 0 or not, or less than 0. Now, if we divided by a negative, then the inequality would actually flip over, and it would be like this: D minus B over A minus C. Doesn't matter that this sign would change or not or whatever. That would be another case that could be possible. This is if A minus C is less than 0. Now, the interesting part is if A minus C is 0, because number one, you can't divide by 0, but the more important aspect of that is if they are 0, then the X is canceled. And if the X is canceled, then you're only left comparing B and D. So if A minus C was 0, if these went away, you'd be looking at B is less than D. And the question would be, is B less than D a true statement or a false statement? If it's a true statement, we have an all real numbers case. If it's a false statement, then we have a no solution case. So what I want to say here is you can have an all real numbers solution possibly if A equals C and if B is indeed less than D. So all real numbers if, give me a second. if A equaled C and B, was it B less than D? And if B was less than D. So if that was a true statement, you'd have an all real numbers case. What would make this a false statement? If A equaled C, which means they would cancel out, right? And then, so, if I said if A minus C is greater than 0, I think that's a better way to state it than if A is greater than C, because that truly emphasizes you're dividing by a positive. But here I want to compare B and D outright, not put them on the same side of the inequality. The last one is no solution, and this would be the case. This problem came up to me by surprise. If A equals C, and if B was equal to D or greater than D, either of those cases would fail this B is less than D scenario. Is 4 less than 4? No. So that would be a false statement kind of scenario. So being equal to D is also a case where you'd have no solution. So those are the different possible ways you can express this. Now D, B, A, and C, again, they're all numbers. They're all numbers of some sort. We can plug them in and make them happen. But once you do, these different things can possibly arise, depending on what you're looking at. Okay, numbers 16, 17, and 18 are the final three here of the chapter test. Then we have cumulative assessment right after. Write and graph a compound inequality that represents the numbers that are not solutions of the inequality represented by the graph shown. Explain your reasoning. All right, let me copy that over. Well, not copy it. Let me redraw it. I'm going to put, as I normally do, how we'd graph it. So like this. Now they're saying what are not solutions. I'm going to begin with what are solutions, just so we can practice some things, right? So this one is originally x can be less than or equal to -3, or x can be greater than 2. Now the not solutions case I'm going to place in green. What's everything that's not less than or equal to -3 in this case? Anything that's greater than -3. So greater than -3 here, all the way up until 2, and then fill in that guy in like that. So what we're looking for as our answer is x is between -3 and 2. The way we can write that is either with the word and, or going in this fashion here. X is between -3 and 2 like this. This is anything that is not a solution to that set. So the drawing kind of helps with that. Looking at this and the opposites, remember instead of or, this is actually an and case. Number 17 looks like an and case, so we can turn this into an or case given what we have. So let's see if we can make that work. Number 17, we're between -4 and -1 inclusive. That means -4 and -1 are solutions to this thing. 0 ain't. But here's the original setup. Whoops. Nope. Here's the original setup here for, listen, I'm calling these x's, by the way. I hope that's okay. So on this one, the original setup is x is between -4 and -1 inclusive. That also means the word and. Now that we're going to split these, we can't be -4, we have to go less than. We can't be -1, we have to go greater than, which includes 0. So in this final set, we're going to say what's not a solution, x must be less than -4, or x must be greater than -1, and then we're all in good faith there. Did they say graph them? No, they just said explain your reasoning, but I drew the graphs, right? These are not solutions. I drew the graphs in green. Follow the green. Okay, last one on the chapter test, number 18, 3 parts. A state imposes a sales tax on items of clothing that cost more than $175. The tax applies only to the difference of the price of the item and $175. If you guys can't see that print, I'm going to copy and paste it into here. So we have information in this thing. It's called the Style Store. And $295 subtotal plus $7.50 tax is $302.50. What do they want out of this? What do you want? Part A, use the receipt shown to find the tax rate as a percent. Okay, it's not really an inequalities question, but tax rate is dividing, they said it only includes for the subtotal price, right? This part, not, oh wait, hold on, what? 170, well, hold on. They didn't say that. I thought they said it was for the subtotal. The tax applies only to the difference of the price of the item and $175. So the tax is dividing $750, and I'll put actually $750 here, by the difference of the price of the item and $175. And there are reasons for why you might not tax the entire thing. I'm not going to get into it, but that could be it. So let's use the calculator for that one. I'm going to pop this guy up, and we get 750 divided by, and in parentheses, if you're going to do this for difference, we have to do that, 190 or 295 minus 175. I don't know where 190 came from. And you get 0.0625. So that is not the percent, though. That is the decimal equivalent of some percent. This is 6.25%. We have to go and shift this decimal 2 places over like that. So not an inequality question, but we might do something with that in a moment. Or they're practicing your taxes. Part B. A shopper has $430 to spend on a winter coat. Write and solve an inequality to find the prices of coats that the shopper can afford. Assume that P is greater than or equal to 175. So I think this is given that we are all also spending. I'm kind of confused on this, actually. Hold on a second. Use state imposed sales cost more than 100. Oh my gosh. Okay, I was really confused on this before. So they're just showing this as an example for how the tax stuff works. This is not a part of our actual purchase of any kind in any kind of way. They're showing you how we're going to use the tax later on. Now, resetting the problem, dealing with the tax the way that we did. Now we're going to do something with this, okay? So we only are paying tax on things past the 175. The first 175 we're not taxed. Now I'm understanding the question significantly more. Okay, so what are they saying? We have $430 to spend. We can't spend any more. We have to be less than or equal to $430. Let's see how much room we need. Now, given that, write and solve an inequality to find the prices P of coats the shopper can afford. Okay, so it says assume that P is greater than or equal to 175. So we're going to spend at least $175. This is an untaxed 175. Now we're also going to be spending an additional P dollars. The thing about the P dollars, though, is, first of all, this additional amount, let's see how I say this. This additional amount is the overall total price you're going to be spending. Let's see. Right and solve inequality. Prices P of coats the shopper can. So you're just coat shopping. I want P to represent the entire cost. You can let P be the difference between these two if you want. I want P to be the entire cost. That means you're going to you're going to spend P dollars, but you got to take away the 175 within that because I want P to be the final amount. The thing is, though, this amount will be taxed. So we have to get a 6.25% increase, which means we do 1 plus 0.0625, which is 1.0625. If that makes sense to me, what we're doing is we're spending this baseline amount here. We're going to solve for a P that represents the total amount, needs to be within $430. And the amount past 175, this is the difference between itself and 175, will be taxed 6.25%. Okay, I think that's my setup. If that's the case, I'm going to go to work. Now I'm going to subtract 175 here. I could distribute. I want to see what happens when I do. Hold on. I'm going to try and do this first. What's 430 minus 175? I'm going to try and divide by 1.0625 and see if this works out. If it doesn't, I'm going to distribute the 1.0625. Okay, it does. So here we go. I have this quantity. This is less than or equal to, and this number here is $255. Now, if you divide by 1.0625, it does divide evenly. And this number becomes 240. So if I add 175 to both sides, right, there's that cost difference. There's the cost difference. This will be P is less than or equal to $415. Is that $415? $415. Now you might wonder why it's not the full 430. And hold on, I just want to make sure that that's right. Okay, it is less than 430. So up to $415. You might wonder why it's not the full 430, because part of this will be taxed. If you spend $415, that means 240 of it, which is literally how this thing's explained, right? 240 of it will be taxed. It'll be taxed to 6.25%. Apparently, a tax of 6.25% on $240 is an additional $15. When you add it to the 175 that you're already spending that is untaxed, that totals to 430. So this is as much you can spend on the subtotal, I suppose, if you will. And that should be it. Part C. Another state imposes a 5% sales tax on the entire price of an item of clothing. So the entire price, not just whatever. For which prices would paying the 5% tax be cheaper than paying the tax described above? Write and solve an inequality to find your answer and list 3 prices that are solutions. So in this other one here, when you're paying the price in full, we're still talking about a price P. This time, the entire price is taxed 5%. So an additional 5% on top of some price you spend is 1.05 times P. Now, what did they want? They want to say for which prices would paying the 5% be cheaper than, less than in price. For what P is this less than what we were doing for the other set? So the 175 untaxed, and then what was this? 0625 times the difference between what you're paying on that part and 175. We want to find what values of P holds up here. So, yeah, I don't love decimals, but, we'll deal. This time I feel like I need to kind of distribute this guy here, just because I need to get, these P's alone. So 1.0625P. Let's hope that this thing also divides or multiplies evenly here. 1.0625 times 175. No, it's not, but it's still, we'll deal with it. 185.9375. Okay. I'd like to keep my P's positive, please. So I'm going to subtract 1.05 from... Oh, actually, you know what? I need to combine like terms here. So I have 1.05P is less than 1.0625P. And then 175 minus this other number I have is 10.9375 and negative 10.9375. So I'm going to subtract this one over. I'm going to add this one over. Maybe that's a little overkill for this one. Maybe I should have kept it on that side. You know what? Let's do that. Sorry about that. That's a little overkill. Let's just subtract this guy over here. And then now we have a couple negatives though, right? And you can't just turn them positive because the inequality is also going to flip. So I have 1.05 minus 1.0625. I think it's negative 0.0125. So negative 0.0125P is less than negative Hey, a lot of work on this stuff, right? Not without a challenge on these. Didn't expect them, but they're here. That should divide you. I think that's multiplying by 80? Because 0.125 is 1/8, so 0.0125 is 80. Now, they're negatives, etc., so this will flip here, and we're going to figure out what prices kind of work and if this makes sense for the final answer. So I'm going to do 10.9375 divided by 0.0125. So there's a chance this becomes a whole number. And it is. It's $875. So given what I have here, P is greater than 875, what's that telling us? It'll be cheaper. Wait a minute. For what? What does it say? For which prices would paying the 5% tax be cheaper than paying the tax described above? It would become cheaper to pay the 5% tax on everything you do once you spend more than $875. So let me kind of type that out. It would be cheaper to utilize the 5% tax on the entire purchase than the aforementioned situation, than the previous situation. It's the weird one, 175 plus 6.25%. If you spend, now not this or more than $875. Needs to be more than that. And that makes sense as far as the situation goes because 5% is imposed immediately on your spending, even though it's a smaller amount. If it's imposed immediately on it, then everything you spend is more. Even though 6.25% is more, you don't get taxed until the $175 onward. So it became an inequality question. Getting that tax to begin with was the start of it. Okay, that was significantly longer than I expected on that one, guys. So that is the chapter test portion. I believe I did that last one correctly then. We're going to go to the cumulative assessment. There's problems 1 through 8. These problems also always get very weird. There are going to be things from chapter 1. But chapter 1 was just solving equations, so I don't really see those as being more difficult in any sort of way. But depends on the questions they ask, right? They can be a little weird. So I'm going to go ahead and get started on these ones, on the cumulative assessment. So number 1 begins with a chapter 2 thing. Or no, it's chapter 1 actually. I saw the absolute values and I forgot. Chapter 1 had absolute values. The expected attendance at a school event is 65 people. That's expected. The actual attendance can vary by up to 30 people. Which equation can you use to find the minimum and maximum attendances? So I was going to say, when it said up to 30 people, I was thinking, why don't they make this an inequality? But they're just referring to the mins and maxes. So they're saying that the difference between the actual attendance and 65, the one that's expected, can be 30 people added or subtracted from 65. That's the plus or minus on the other side of the absolute value. So our min and max of an absolute value can be 30 in either direction. That's the difference between our value and 65. So which option is that? Looks like it's A. It's not going to be B or D with the plus, and it's not going to be C because we're not doing the difference between our number and 30. It's the difference between our number and 65. That answer's A. Number 2. Fill in values for A and B so that each statement is true for the inequality shown. So I'm going to write the inequality. I'm going to copy and paste those things into here. And let's see what the heck they are talking about and how we can best solve it. Okay, let's see. Sorry, I got to shrink it to size here. Okay, part A. When x equals 5 and b equals blank, x is less than or equal to negative 3. Well, we probably got to do some work for that. When a is 5 and b is something, x is less than or equal to negative 3. Let's subtract 3x from both sides and subtract 4 from both sides. I now have 2x is less than or equal to b minus 4. When I divide both sides by 2, I get x is less than or equal to b minus 4 over 2. Now, what I want to do is, we can guess and check, and I guess that'll kind of be the idea. Okay, fine. I'll write b minus 4 over 2. What I want to do is I want to show it says less than or equal to negative 3. I need b minus 4 over 2 to equal negative 3. I don't want to guess and check. I want to actually kind of solve it. So we're going to multiply both, not by negative 2. We're going to multiply both sides by 2. We'll get b minus 4 equals negative 6, and I'll add 4 to both sides, right? Solve everything fully algebraically. This is just part A, right? So b equals negative 2. So for this to work, b is going to have to equal negative 2 for x to be less than or equal to negative 3. Let's double check that. So x is less than or equal to negative 2 minus 4 over 2. That's negative 6 over 2, which is negative 3. Okay. That's part A. Part B. When A equals blank and B equals blank, the solution of the inequality is all real numbers. So to get all real numbers, I think this is one we can do without showing work. A would have to be 3x, or 3, for the 3x's to cancel, for us to even have this situation to begin with. So A would have to be 3 straight up. For this to work, B can be, it says 4 is less than or equal to B. As long as that's a true statement, B is good. So when A equals, and B can equal, you have more than this. I want to write this as an inequality. I want to say if B is greater than or equal to 4. I want to say that. So if B is any number that's 4 or more, then it satisfies the set that 4 is less than or equal to B. So I can choose any, or I can choose 6. As long as it's not less than 4, then you have an all real number statement. So that's open-ended. It says fill in values for A and B so that it is true, not the values. When A equals blank and B equals blank, the inequality is no solution. Well, that's back to A needs to be 3 again. A has to be 3 for those parts to cancel. Now, okay, so now we need to fail this thing. 4 is less than or equal to B. We need to make it false. I'll make B 0. It needs to be something that's less than 4 for that to work. So the only one that needed work was part A, which is kind of good because I didn't know how to scroll up and down other than that. And I'll leave that as is. Where did this come from? Oh, right here. Okay, oh, I didn't move this thing down. I'm so sorry. That was number 2. Number 3, now that I move it down, place each inequality into one of the 2 categories. At least one integer solution or no integer solutions. They're talking integers. So I guess we might have to solve all these because they're talking about they're not talking about just solutions. They're talking about integers. But at least one integer solution. So now we don't have to solve in full. We just have to figure out, ultimately, we can go one step less if we say, oh, can we divide by that number? That kind of thing. So 5x plus x is 6x. And then I can subtract 2x from both sides as I add 6 to both sides. This will be 4x is greater than or equal to negative 2. This will have no integer solutions. Oh, wait a second. I take that back. These are inequalities. Does that count? This should have integer solutions, right? Because this, okay, hold on. This is x is greater than or equal to negative 1/2. I was thinking, oh, negative 1/2, that's not an integer. But time out. X can be greater than or equal to negative 1/2. X can be 0. It can be 1, 2, 3, 4, 5. Those are integer solutions. So this one has integer solutions. So I'm going to, yeah, this one totally can. Sorry about that, now that I'm totally realizing what's expected for us. So I'm going to fit that one. I will place you right there, assuming that's what they meant. So the no solutions cases, I don't really know which ones will be that yet. We'll find out, because they don't have absolute value ones here. So we'll see. Oh, variables can cancel, right? That's what I should be looking more toward. Maybe we don't have to do as much work as I thought. Guys, maybe we don't have to do as much work as I thought. Here's what I think we have to do. Because we've solved a lot before. Let's do this. Let's find ones that'll have variables cancel. Now, if it's an all real numbers case versus a no solution case, we'll have to do that. If the variables don't cancel, there's no reason it won't have integer solutions in my mind. That's where I'm going with this. Now, we just got rid of that one because we said this hasn't. Take a look at this next one, though. When we distribute, this becomes a 6x on this side and a 6x on that side. Suddenly, things are a little bit different for this one. Now, I'm going to show as little work as possible. If the 6x's are on both sides, they'll cancel out. You'll be left with 2 times 8, which is 16, is greater than 3 times 6, which is 18. 16 is not greater than 18. Therefore, that doesn't have any solutions. Not just integers. It just doesn't have any solutions. So, much less integers. So I'm going to bring that one to this side. I hope that made sense on how I went about that one, given that the variables canceled. And really, that's what I'm looking for. Which one will have canceling variables? So yeah, I am going to try and avoid doing all the work if possible. This one here should have, oh, this one's a little different because this is a compound inequality. Okay, now I'm fully seeing what they're going with. Sometimes we do have to do more work than that. Because what if we have a compound inequality that's between 1/2 and 3/4? You won't have integer solutions in that set. So let's try this one. 17 is less than 4x plus 5, which is less than 21. If we subtract 5 among all these, sorry if I feel like I'm trying to cheat the questions. I'm really not. What I'm trying to do is optimize the questions for what they have. So that's 16. If I divide by 4, oh, check this out. Check this out. This is, x is between 3 and 4. But x doesn't include 3 and 4. So it doesn't even need to be fraction numbers here. These integers aren't enough. There is no integer value between 3 and 4, not including 3 and 4. So that also has no integer solutions. Okay, I like the format of this question. It's just a lot to do, right? When I say there are only 8 questions, well, this has ideally 6 parts. But really what I'm doing is I'm playing more of the strategy of it as much as I can so I don't have to do so much work, possibly. All right, next one, x plus 4. Okay, hold on. So what I'm looking at here, I hope this is okay for me to say. X plus 4x is 5x, okay? 3 times x is 3x plus 2x is 5x. I do have 5x's on both sides, which, guys, will cancel out. So what I want to do now is look to the numbers that are not the variables. I have negative 8 over here. And then I have 3 times negative 3 over here, which is negative 9. The question is negative 8 less than or equal to negative 9? That's ultimately all I'm looking at. I know I could have written a lot more, but I want to get some of the mental stuff in. Is negative 8 less than or equal to negative 9? It's not. It's not. That doesn't have any integer solutions either. So that, yeah, because the 5x's go away. So getting that one, really small print in there. I don't know how many will be for each set, so I'm doing what I can. This is really hard to, this software does not always play with me right. All right, next one, there's an OR case. An OR case will probably be satisfying this. If I add 15 divided by 9, I'm getting answers there. The OR, this is totally good for having solutions, guys. Integer solutions, I should say. An OR case especially, if it's solvable, and it is, you're going to get them all over the place. Remember, there's an infinite number of solutions beyond going less than whatever number that was. Or the other one. And the final one has 5. So the variables will cancel because 5 times x is 5x, so it'll cancel with that 5x. But this 5's got to multiply with -1, and it'll be -5 is less than or equal to -3. Now that's a true statement, which means this is actually all real numbers. If it's all real numbers include integers. That means this has at least one integer solution, if not many, 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 many. So yeah, 3 per, liking that. I'm just going to fit it right in there. That's my answer set. I hope it's okay that I'm fitting them in these boxes. You're following along. Boom. Boom. Okay, number 4. Admission to a play costs $25. A season pass costs $180. Write an inequality that represents the numbers x of plays you must attend for the season pass to be a better deal. Better deal to me means you need to spend less for that one. So we need 180, that amount, to be less than, right, 25 times the number of x plays. Like that. I think that's just my setup. It needs to be less than that amount. They didn't say solve it, but part B, select the number of plays for which the season pass is not a better deal. Okay, let's just first solve this one. We divide this by 25, and by the way, this does not divide evenly. But this here says, hold on, I should know this. 7.2, let me make sure. 180 divided by 25. 7 quarters plus another 5 cents. Yes, 7.2. So 7.2, or x is greater than 7.2. That means 7 plays or less, the per play admission's a better deal. More than 7 plays, the season pass is a better deal. So more than 7, well, it says 7.2, but that's plays are by integers. More than 7 plays makes the season pass a better deal. Now, they said, which makes season pass not a better deal. That means for part B, because part A this is technically part of part B, but less than 7 plays. Less than 7. If I want to do a compound inequality, I'd say from 0 to 7 plays, but less than 7 plays makes the season pass not a better deal. Which means, let's find any number that's less than 7. Anything from 0 to 6. No decimals, fractions, or negatives should be a part of this. Oh, this goes in order. 0, 1, 2, 3, 4, 5, 6. So these ones, you're spending too much on a season pass if you see 6 plays or less. Okay. Number 5. Select the values of A that make the solution, chapter 1. 3 times 2x minus 4 equals 4 times ax minus 2 positive. Let's write that out and see what they're going with here. Select the values that make this positive. All right, let's go distribution and all that stuff. So we got 6x minus 12 equals 4ax minus 8. Let's get the x's on one side of the equation. This is more of a literal equation kind of problem, given that we do have this extra a in place. I want to kind of get a solution for x all involved. Remember, these cannot combine because this has an a in it, but we can subtract 6 minus 4a. I think we said this earlier in this video, and multiply it by x, given that x factors out, and negative 8 plus 12 is 4. If you divide both sides by 6 minus 4a, then you solve for x. So x equals this guy here, 4 divided by 6 minus 4a. Now they said find the values of a, values that make this positive. I guess technically this goes from a chapter 1 thing to a chapter 2 thing. I want this to be a positive number. That means I want this to be greater than 0. 4 over 6 minus 4a is greater than 0. Now, you haven't done a lot of things like this when it comes to solving. We won't technically write it like this. Here's the understanding. 4 is a positive number. We need this to be a positive number. Positive over positive is positive. And it can't be 0. So 6 minus 4a must be greater than 0. Suddenly it turned into an inequality question. I'm going to go ahead and add 4a to both sides and say that 6 has to be greater than 4a. Divide by 4. So 3 halves has to be greater than a. Now that's 1.5. That's a has to be less than 1.5. If a is any number more, 1.5 or more, if a is 1.5, you divide by 0. You can't have that. If a is more than 1.5, it becomes a negative number. You can't have that. So which ones make it positive? Numbers that are less than 1.5. That includes these ones here. So the ones that I cross out are no-goes, and these ones work out. So we can be -2, -2, -1, 0, and 1. I didn't write the answers for this one here. I just said less than 7 plays. I hope it's okay that it's 0, 1, 2, 3, 4, 5, 6. And yes, you can see 0 plays and benefit. You buy a season pass and attend 0 plays. You're not season passing, right? Anyway, that's the answers for number 5. Number 6. Are we gonna go past the hour mark? Oh, maybe not. Fill in the compound inequality with less than or equal to, greater than equal to, or greater than, so the solution is shown in the graph. Okay, so we have 4. Let's just copy that whole thing in, because it's already made, and we have to fill in. So this will be, fill in the villain. All right, can you see that whole thing? Yes, you can. All right, 4x minus 18 is blank compared to this and that and that. Okay, well, we might have to do some work instead anyway. Let's do this. Let's treat this like an equal sign temporarily. Figure out how these problems work out as a whole. Sorry, don't actually put anything there. Treat it like an equal sign temporarily. Figure out what this thing as a whole, which boundary point represents the -2 and the 3, etc. We'll change that up as we decide what we have to do. I have to add, here's the thing, it's not going to be equals, because I don't think it can be. Well, maybe it can. We'll see. I think it needs to be inequalities only, because we have to be between two numbers. So anyway, we're going to add 18 to both sides. We get 5x equals, or whatever, 15 divided by 5, we get x equals 3. Okay, so here's the thing. I now need to change this to something, right? 3 is this boundary value we're talking about. We need to go on this side of 3, and we divided by a positive. Positive here, that means the inequality never flipped. If it never flips, then that means this would have started, we go down to the less than, then this trickles up into here, and then this becomes a less than. So this must be less than 3, and we have the and satisfying the other part. So this part needs to be the -2. The difference on this problem here is this has a negative coefficient. So I want you to imagine, temporarily will be equals. I want you to imagine what it is we're going to have to do to set inequality, as this should give us that -2 setup. Divide by -3, you get -2. However, we need to be greater than or equal to -2. So if this is greater than or equal to here, does that mean we put greater than or equal to here? Not necessarily, because we divided by a negative. That means there the inequality flipped. It was a less than or equal to at some point for that to happen. So I believe this has to be that in order for it to become what we want here in the and case. I like the way that those things work whenever they're like, hey, you got to do this, you got to do that. Because we got to explore it a little bit more and say what happened. So the temporary equal sign was just a solve. We could have put a box the entire way, but we replaced it. We're good. 2 more questions. Number 7, you have a $250 gift card to use at a sporting goods store. Write an inequality that represents the possible numbers x of pairs of socks. That's a weird question. You can buy when you buy 2 pairs of sneakers. Can you buy 8 pairs of socks? Explain. Okay. We have a sale price of $80 on the shoes and $12 on the socks. Write an inequality that represents possible number x of pairs of socks you can buy when you buy 2 pairs of sneakers. You have a $250 gift card. Okay, so we can buy 2 pairs of sneakers. I assume the sale price is a part of this, right? 2 pairs of sneakers for $80 as the set. You spend $12 on each pair of socks. You multiply by the number of pairs of socks, x, that you want, and we cannot exceed $250. Therefore, we must be less than or equal to $250. 2 times 80 is 160, so we get this setup here. They said, write the inequality. They said, can you buy 8 pairs of socks? Explain. We can either solve this or we can substitute. Before I decide, I want to see if part B would benefit if I solved it. Part B, describe what this inequality represents in this context. Okay, I'm going to save that for now. So I'm going just to do a substitution. We can check and see if things are solutions through substitution. Part A, does 160 plus 12 times 8 stay less than $250 or equal to? That's 160 plus 12 times 8 is 96, right? I don't do 12s anymore these days. 250. 160 plus 96 is 256. 256 less than 250? No. Equal to 250? No. I wish they had one that was equal to, so we can remind ourselves that less than or equal to means that that's good. So we cannot buy 8 pairs of socks because our total, because we're poor, because our total would amount to $256, which of course is more than 250. That's part A. Now part B says, describe what the inequality 60 plus 80x is less than or equal to 250 represents in this context. In this case here, I think what's happening, because we're not... I know the answer. I just want to figure out how to say it to you guys. We're not restricting X to have to be number of pairs of socks anymore. Part A is its own problem. The 2 pairs of sneakers, the same thing. A is a different problem than B. So when you see 60 plus 80x, 80 is not a multiple of 12. So 80 is a multiple of 80, and 60 is a multiple of 12. So this time, the 12 has to do with the 60. That's $12 per sock times 5 pairs of socks. The 80x is $80 per pair of sneakers times the number of pairs of sneakers. So when we write this, this is, to me, this is, the situation is, you buy 5 pairs of socks. And I don't know if we're supposed to solve this. I don't know if we're supposed to make it as a question or just a statement and X pairs of sneakers, or determine the number of X pairs of sneakers you can buy to stay under budget, to not exceed gift card expenditure. I don't know. With your gift card. So that's what I think this one is right here. That's how that one makes sense. Okay, last question, number 8. Just a few minutes on the clock before the hour tick, tick, tick mark goes. And 3 parts. I don't know if we can pass it. Number 8, consider the equation shown. Where A, B, C, and D are integers, it's an equation. But as we saw on the previous problem, it turned into an inequality at some point. Student A claims the equation will always have one solution. Not true. Student B claims the equation will always have no solution. Not true. Use the numbers shown to answer parts A to C. Student A and B are no. Select values for A, B, C, and D to create an equation that supports student A's claim. For student A's claim, one solution. A and C just have to be different numbers. That's it. A can be 1, B can be 2, C can be 3, D can be 4. Boom. As long as A and B, as long as A and C are different, they won't cancel. B and D can be the same. They can equal 0. All that X can equal 0. That would be one solution. Totally fine. Part B. Select values to support B's claim. To be no solution, B and D have to be different. A and C have to be the same. How about A and C are both 1 this time? And B and D are still just 2 and 4. This would make 1x plus 2 equal 1x plus 4. Subtract those. 2 equals 4 is not true. And part C, select values for A, B, C, and D to create an equation that shows both student A and student B are incorrect. Well, both of them are incorrect. I was going to say, this one shows that B is incorrect, and this one shows A, or whatever. Yeah, B is incorrect, this one shows A is incorrect. I guess we have to do something for both. So we need to have an infinitely many solutions kind. So we need A and B to be the same, or A and C to be the same, and B and D to be the same. So 1, 2, 1, 2 would work out in that case. That would wipe out the X's, and it would say 2 equals 2, and that would work there. Not much to do on those ones with those 3 parts. That means we're going to go within the hour mark. So guys, that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. That is the end of Chapter 2. Hopefully everything we did with the equations and inequalities flowed really well, especially within the cumulative assessment. It shows how they can blend together. It shows how you can mix and match and kind of get a feel of why we use what and when, which is great. Coming up on Chapter 3 is going to be, I believe, with functions? I got to see. Linear equations or functions or something like that. But you'll see when the videos come up. So guys, thank you so much. Take care. I'll see you in the next one.